let's learn a very important concept, and it is nothing but a theorem, and that is converse of BPT. We have already learned BPT and we have also learned converse of BPT, but only the application. Now let's prove the particular theorem. The statement says that if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Now let's understand this in parts. It says if a line divides two sides of a triangle. So the very first thing is we are going to draw a triangle. So let's have a triangle, that is triangle ABC. It says line divides two sides. So that means there is a line which divides any two sides. So let's consider two sides to be AB and AC. And there is a line which divides AB and AC at points D and E. Now tell me, line D divides AB in which two parts? Yes, we know that it is AD and DB. Beautiful. Same way, line DE divides AC in which two parts? It is AE and EC. Beautiful. It says in the same ratio. But now only focus on the words in the ratio. Ratio means something upon something. That means it is AD upon DB and AE upon EC. It says in the same ratio. That means the ratios are equal. So if AD upon DB is equal to AE upon EC, this is given to us, then the line is parallel to the third side. Now but here in this triangle, which is the third side? We know the third side is BC. That means we are saying that we need to prove DE is parallel to side BC. Now this is the given and the to proof. We have understood what to draw also, right? Now let's proceed further. Now students, remember, this theorem happens to be very important because this is done by a different method and it is called as indirect method. Now what happens in an indirect method is that we always start with an assumption. So this method always starts with an assumption which is exactly opposite to the to proof. So right now here, what is the to proof? We know the to proof is line D is parallel to side BC. So what is the opposite of this? The opposite of this is that line D is not parallel to side BC. So this is going to be the assumption. So remember students, whenever you do a proof by indirect method, you always start with an assumption which is exactly opposite to the to proof. So we write here that let us suppose that line D is not parallel to side BC. So now what happens in an indirect method is you make an assumption and on the basis of that go on proving, and ultimately you will realize that your assumption was wrong and whatever was your to prove is correct. So now let's on the basis of this assumption, let's start solving. So we have assumed that D is not parallel to side BC. But students, understand, when we have BC and a point D here, which we see, if we have a line and a point D outside the line, we know that whenever there is a line and a point outside the line, there exists a line which is passing through that given point and also parallel to the given line. That means if DE is not parallel to BC, then we need to have another line passing through D which is parallel to BC, because there has to be a line which is parallel to BC, and we draw DF parallel to BC such that it is A dash F dash C. That means F is between A and C. So on the basis of that assumption, we had to draw something, and that is what we have drawn. DF is parallel to BC. Now observe students, in this triangle we are saying that line DF is parallel to side BC. So in a triangle, if a line is parallel to a side, which theorem can we apply here? Yes, it is BPT. So let's apply BPT here. So if we apply BPT, what do we get? In triangle ABC, we have that line DF is parallel to side BC. Therefore, we have AD upon DB is equal to AF upon FC. And let's say this happens to be our statement number 1 by BPT. Was this clear to everybody? Beautiful. This is what we got. So we got this right on the basis of the assumption what we did. But what is given to us? We already have that AD upon DB is equal to AE upon EC. And let's say this is our result number 2. Now observe result number 1 and result number 2. What do we observe? Yes, we get the left hand side to be equal. If the left hand side is equal, what can we say about the right hand side? Right hand side will also be equal. Now we'll write now in the next step, therefore we get AF upon FC is equal to AE upon EC, and the reason for this will be from 1 and 2. This is what we got, right? Now I want you to go through this, think over it and think what we can get further. I'll be back.